Hello, my name is Panchel and welcome to Minecraft Math. Today I would like to show you how you can generate data describing some motion in Minecraft that you can later use to work with in Google Sheets, for example. That's the program that I'm going to use. I generate the data using this command block. Every tick, it will execute this command and print my coordinates in chat. I can then access the data in the log file that's saved in the .minecraft folder on my computer, and I can import it into a spreadsheet and work with it there. To activate it, I just place a block of redstone next to the command block, and immediately it starts printing my coordinates. You can see the middle one is 4.0, and when I jump, it increases. The middle coordinate is the y coordinate that corresponds to the height. The first motion that we're going to collect data about is just me randomly jumping, sprinting, and walking about. And before we do that, I have to first write, for example, random movement in chat. That will separate data from the previous experiment from the next one, so I can tell them apart. Once I've done that, I can just place a block of redstone next to the command block and start moving. Let's jump around. Do a little bit of sneaking even. Jump, jump, jump. That's good enough. Okay, so the data is already collected in the log file and we can use it from there. The next three motions that I'm going to do will be me riding in a boat. First on regular ice, then on packed ice, and then on blue ice. Blue ice should be noticeably faster than the previous two, but we'll see from the graphs what it's actually like. The next three motions that we're going to measure will be me moving in a boat on regular ice, packed ice, and blue ice. Just like before, I have to start the experiment by writing, for example, boat ice in chat, and then placing a block of redstone, and let's start moving. At the end of the track, I have a pressure plate that will take me back to the beginning of the track and also immediately remove the redstone block. That way I can start the next experiment right away, but first, boat, packed ice, and we can go. I believe that when we're riding on packed ice, it's actually the same speed that as regular ice, but we shall see. Okay, so that's the second one. The third one, boat, blue ice. Place the block of redstone and let's go. This time we actually overshot because we're moving so fast that the pressure plate didn't register us moving over it. We can teleport back there, check, yes, it's actually working. We just went so fast that it didn't register us going over the pressure plate. The next experiment that I'm going to do will be free fall. This command block will teleport me 250 blocks up and let me fall to the ground. So let's name the experiment free fall, place the redstone and get teleported. I am now falling to the ground, and once I land, I can immediately break the redstone and end the experiment. The last experiment that I'm going to do will be riding on this llama that is suspended in the air. I hope to see some kind of sine function in the movement, but I'm not sure. So let's start the experiment by calling it llama, placing a block of redstone and sitting down. You don't actually move side to side, only up and down. A few seconds should be enough. Okay, let's end the experiment by breaking the piece of redstone. Now that we have collected all the data, we can go into Google Spreadsheet and look at the graphs of the motions. First, some background. Minecraft runs in ticks. One tick is 1/20th of a second. It is the time that the game takes to recalculate all the values that it needs to. For our purposes, one tick, or 1/20th of a second, will be our delta t that we will use in our calculations. To calculate the distance, we will use Pythagorean theorem in 3 dimensions. So we will have to find the differences of the x, y, and z coordinate between two ticks, square them, add them together, and then take the square root. Since instantaneous speed is the derivative of distance with respect to time, and Minecraft is a discrete game that runs in ticks that have a length of 1/20th of a second, we cannot really do anything such as actually instantaneous speed, but we will take the next best thing, which will be average speeds between two ticks, which will be delta s divided by delta t. The same thing applies for acceleration, which we will calculate as delta v divided by delta t. If you navigate to your .minecraft folder, you can find folder logs inside of it, and there a notepad document called latest. When you open it, you can press Ctrl F to search for the name of the experiment. I have already done that. The first experiment was random movement. You can see I wrote that in chat, and then the command block started printing my coordinates because I placed the redstone. I will now copy all these coordinates into a new notepad file because I will have to import them into my Google spreadsheet. So I go all the way down here and copy it into a new notepad file. I have pasted the data into a new document, called it the data holder, and now let's import it into Google Spreadsheet. In Google Spreadsheet, I will click File, Import, Upload, and then select the file that I called data holder. I'll wait for it to upload. And now, import location. We want to choose insert new sheet because we don't want to open another spreadsheet. We want a new sheet in this one. And the command that I'm using in Minecraft uses a space as a separator. So let's select separator type, custom, and here space, import data. And you can see we have all the data that we pasted into the data holder notepad file. Now let's do a few changes. First off, all these numbers have a D as the last character in them. I suspect that's because it's a double type of number, but I'm not sure. If you know, please let me know in the comments. If you select all the numbers and press Ctrl H, you will open Find and Replace. We can find all the Ds and replace them with nothing. Replace all, and as you can see, all our numbers are actually numbers right now. We will also insert one more line at the top because we want to name our data. So E currently is the X coordinate. X coordinate is in meters. Y coordinate is also in meters, and the Z coordinate just as well. Now, next to the coordinates, we only need two columns. So let's delete 2 and empty the contents of the other 2. The first one will be the tick number. That will serve as a numbering for our ticks. So 1, 2, 3, 4, and so on. I will actually do it like this. The first one is 1, and the second one is the previous one plus 1. Because now I can just copy throughout the spreadsheet, and it will automatically number my lines or ticks. I will also add a constant. That is 1 tick in seconds. We know that 1 tick is 1/20th of a second, so that's our time constant. We can also use this knowledge to calculate the actual time that has passed since we started the experiment. So that would be in seconds, and that's the tick number times the length of the tick in seconds. Now, this is a constant, so I need to press F4 to lock the value, press enter, and then autofill. You can see that after 20 ticks, 1 second has passed, and so on. Let's now also make the sheet a little nicer by aligning to the center, and we will also border the 3 coordinates. Now we can use our formula for distance to calculate the distance we have traveled between 2 ticks. So that will be distance in meters, and the first one is 0. In the first tick, we haven't moved yet. In the second tick, we can calculate it as the square root of the squares of differences. So that's C3 minus C2 squared plus, and now the same for the y coordinate and the z coordinate. We will press autofill, and we can see that in the first 15 ticks we were standing still, and then something started happening. I also don't want as many decimal places, so let's get rid of those. I guess 3 decimal places will be enough, and I want my zeros to be exactly zeros. A little correction, this is of course delta s. The difference of the positions is the distance we have traveled. Now that we have delta s and delta t, we can calculate speed in meters per second. Speed is just the difference of distance divided by the difference of time, which is our shortest time interval, the 1 tick. And that's a constant, so let's again press F4 and autofill. Perfect. Now that we have speed, we can also calculate the difference of speed between individual ticks. So that would be delta V in meters per second. The first one, of course, is 0, and the second one is simply that one minus that one. Yep, perfect. Using speed, we can calculate acceleration, and that would be in meters per second squared. Acceleration is delta V divided by delta T, so let's plug that in. Delta V divided by delta T. Again, delta T is a constant, so let's press F4. Now that we have the data collected, let's check that it's all correct. We have many lines extra, so let's delete those. We don't need them. Now we can insert a chart, and we will select scatter, delete the series that's already in there, and for our x-axis, or rather horizontal axis, we will use time, which is the column B through B. As our series, let's start with speed, so that's column G through G. Perfect. Let's look at it. We can see that we weren't moving at all at the beginning. Then we started moving, jumping. This is also running. I believe this is the sneaking that I did. And then a few more jumps at the spot, and then not moving again. Now, let's give the graph some proper name. This is speed of random movement on time. That's the chart title. The horizontal axis is time in seconds, and the vertical axis is speed V in meters per second. Perfect. Let's now copy the chart and paste it, because we're going to use the same format for acceleration. So let's rename it to acceleration and change the vertical axis to acceleration and in meters per second squared. We also need to change the series, so let's remove it and add in a new one. This time acceleration is the column I through I. Perfect. Now that we have the graphs, we can take a look at them. At the beginning, we're not moving at all, so there is not even any acceleration. But as soon as I start moving, of course, I need to be accelerated to move. So apparently, when you start running, you accelerate with an acceleration of 40 meters per second squared, which is about 4 Gs. These high peaks are jumping, and that's about 15 Gs even, 13, 14 Gs. These ones right here, 17 Gs when you're standing still and just jumping. We can also see the speed of sneaking, which is about 1.68 meters per second. All right, so that's the two graphs for speed and acceleration for the random movement. So let's rename this sheet to random movement, and let's do the other ones. The way I'm going to do it to save myself some time is I'm going to duplicate this sheet and rename it to boat on ice, because that's the one we're going to do next. I then again grab the data from the latest log and paste it into a new data holder. And now, using the same method as before, I will upload the new data holder. So it's uploading. Again, we choose insert new sheet and custom space separator. So this is the data. This time we're going to change the D's into nothing again, and then copy the data and paste it right here. We have saved ourselves some time because the table is already prepared. The only thing that we have to be cautious about is the length of the data set. This data set ends on the line 177. The one from random movement was longer, so we need to get rid of that data because it doesn't belong to this experiment. Now we can take a look at the data and we can see that there is a very nice curve as we were accelerating on the boat. There are a couple of strange points though. This data point is actually caused by me entering the boat, because when you right click a boat, you are teleported inside of it. So it thinks you travel a lot of blocks in one single tick. Now we want to truncate the data that we have collected, and we don't really care about anything that happened before we got onto the boat. So this line, the one that contains the 3 zeros, that actually tells me that we were stationary for a while, and that was probably because I entered the boat and it took me some time before I started pressing the forward button. So I think all this data is not necessary. So let's remove it. We will get a couple of errors. First off, the tick number doesn't make sense because there's not a reference cell. That's because this one is supposed to be the reference cell. Again, delta S is calculated as the difference of the coordinates in one tick and the ones before, but there is no before tick. So this one has to be 0, and the same applies for velocity. Now we can put the two graphs back and take a look again. Now we can see from the graph of speed that our speed was gradually increasing, and that means we had positive non-zero acceleration. That is seen on the graph below as well. We can also notice that acceleration is going down, but not fast enough. It never crossed 0. And if we take a look at the trend line that Google gives us, now this is not the best approach to trend lines, but it's good enough for our purposes. So I'll just click trend line, and it looks like it's an exponential one. So let's select that, and we'll make it a different color so we can hopefully see it better. Not really. Now we can see that the trend line very closely hugs the data points. So my guess is acceleration on a boat really does decrease exponentially, which means mathematically that it will never reach 0, which also means that we should keep speeding up forever. Now, I do not know what happens at extreme speeds. There is a certain speed that once you cross it, your computer won't handle it, of course, but for low enough speeds, this seems to hold. Now, let's take a look at boat on packed ice. I will import the data the same way I have done now, and again, I'm going to paste it into a prepared table for the random movement. Okay, here we go. Again, I cut off the data that was from the previous experiment, but again, we can see that we teleported inside of the boat. So let's get rid of those. Okay, so this is what the data for the boat on packed ice looks like. It's nearly identical. We will have to put all the data or all the graphs into one so we can compare them. But let's for now import the data for the blue ice. This is the data for the boat on blue ice. I have already gotten rid of the teleportation at the beginning, and I'm sure that it doesn't contain any unnecessary data from previous experiments at the end. Yet, there's some shenanigans going on. Now, when I rowed the boat, I actually went over the pressure plate that was supposed to terminate the experiment, and I slowed down very rapidly on the grass because the boat doesn't move fast there. I then jumped out of the boat, which again teleported me. I stood still for a second, then probably jumped, ran to teleportation pressure plate or something. Yeah, jumped again and then was teleported back, and it ended the experiment. So all this data is my movement after I have gotten with the boat through the finish line. So we don't need it. Okay, so this is what the graph looks like now. Again, it looks very much the same. The only difference is there are fewer points. And that tells me that the boat on blue ice traveled faster and therefore didn't take as many ticks to get to the finish line. Let's put all those graphs together in one graph. I have put all the speeds and accelerations of the boats on ice, packed ice, and blue ice into one giant table. And now I can again insert a chart. From the graph, we can immediately see that we have only two lines because the line for regular ice and for packed ice actually overlap. The blue ice is, of course, much faster. Let's also check the acceleration. We can see that they all start at the same acceleration, 16 meters per second squared, but the blue ice lowers the acceleration slower. Let's now take a look at free fall. I have already gotten rid of all the unnecessary data for this graph, and we can see that when you free fall, you do accelerate, your speed goes up, but not as you would expect. There is not a constant gravitational pull. In the first tick, you actually accelerate with acceleration of 62 meters per second squared, or about 6 Gs, and then it immediately goes to half of 30 meters per second squared. Now, this tells me that maybe it actually starts at 31 and there's some kind of discontinuity here that makes this point go up, even though it shouldn't. I tried to recreate this experiment multiple times. It always came out with 62, and I don't know whether that's correct or not. Please feel free to try it for yourself and maybe come up with an explanation whether this is correct or wrong. You can also see that the acceleration slowly decreases, and the last acceleration that we experienced was only 3.7 meters per second squared. Let's now take a look at the last data set, and that's for the llama. This is the graph for the llama, and I actually have to expand the table because we had more data points in this experiment than with the random movement, which is the one that I was copying. That's why you can see random movement. Let me correct that. Now that that's been fixed, you can see that I placed the redstone block. I then ran to the llama and I got teleported onto it. I can also see that there are some short peaks and some long peaks. Probably, depending on the extension of the lead, the llama either swings in short bursts or long bursts that they also take longer time. These are all the graphs I have prepared for today, but I would love to see what kind of motions you can come up with, what kind of graphs, and whether you can find something interesting. For example, I never realized that teleporting onto a boat or a llama actually causes me to accelerate so much. But yeah, there's negative 100 Gs I have been subjected to. Well, that doesn't sound healthy. I would also like to thank Grant Sanderson for making me do this. I've been wanting to create educational videos for a long time, especially in Minecraft, but I was having cold feet, and I must say it was a great learning experience. It's very difficult, and I hope I'll be doing better next time. Anyways, that's it from me for now. Thank you for watching, and see you next time.